Welcome back to Chapter 8, Section 4. We're starting with page 301. So if you've read this section, that would be a good idea that you've read this before the video. But now all we're going to do is basically just rearrange one of our equations and show how we can actually calculate the hydronium concentration from pH. Okay, so earlier we were finding the pH. So in the previous video we were finding pH given the hydronium concentration. So now we want to do the reverse. And so really what essentially is happening is that we are going to, just like in algebra class and so on, you can rearrange. So our pH equals the negative log of our hydronium concentration. When we actually rearrange this equation, and sometimes it's hard to see the mathematical functions, but what actually happens is that we can rearrange it and our hydronium concentration that's equaling I'm going to try to explain this on your calculators, okay? But basically on my calculator it's the second function log, so it's that 10 to the power of x in the back side of your calculator. Okay, and so you're basically just taking the inverse log. So or on your calculator it may be the inverse log key. Okay, and so below here it has on the calculator. So to enter the pH, change the sign, and then hit the inverse log key. Okay, for some of you that have graphing calculators, what I do is I press second function log, and then if it doesn't put parentheses there for me, I make a parenthesis. So I would put, so basically I push second function, and then I press log. Okay, and so what shows up is that I have this, and then I put in a parenthesis, and then I put in negative pH. Okay, so we had negative log in our previous when this was being rearranged. My students laugh at my squiggly line for rearrange, but that's just something that I like to do. So it means to rearrange the equation. Obviously not a math teacher here. But then we're going to say to the negative whatever the pH is. So in this example, our pH is 3, to be negative 3.0. Okay, so when you put that in, negative 3.0, don't forget that negative. We will come out with the wrong answer. We get 1 times 10 to the negative third, which is what we expect. This one's the easy one. We've got an even pH, and so 1 times 10 to the negative 3 is going to be our hydronium concentration. So we have found the molarity. So the molarity is the concentration. Back in Chapter 7, I told you guys that molarity is one of the most common ways to express concentration. So you're seeing that here. Okay, we want to know the hydronium concentration of a solution with a pH of 10. Okay, so what we would do, now that we've shown how we rearrange the equation, we are going to find the hydronium concentration by plugging in second function log. It's going to put us to the negative pH. Okay. So once again, we have an even number, but this is just hopefully getting you used to your calculators. But we should end up with 1 times 10 to the negative 10th power molarity. Okay. Now we're asked for the hydroxide concentration. Okay. So we've got to think about what we're going to do here in order for us to get from pH, because remember pH goes along with the hydronium concentration. This is what we've been looking at so far. Okay, but now we have hydroxide, which goes along with POH. So there's actually 2 routes you can take, but the route that I use is I know that my scale is out of 14. So I know that pH plus POH equals 14. So if I subtract out to find POH, I know that my pOH is going to be 12. Okay, so 2.00 is what I should have been putting here. I apologize. 14. That should be 0.00. So my pOH, our pH is 2, so our pOH is 12. Okay, and so from this point, I can do the same thing. So if we go ahead and we take 10, so we're finding the hydroxide concentration, and take 10 to the power of negative 12. Okay, so if we do second function log, parenthesis, if you have to put that in there, to the negative 12, we get 1.0 times 10 to the negative 12. Okay, you may be thinking that you could go another route for this problem, and that is true. I'm going to erase everything. Okay, another way that you go about working this problem is, if this may make a little bit more sense to you or be a little bit more familiar, but we can go ahead and find hydronium concentration. So we have our pH, so we would take 10, I keep saying 10, but I mean to say that it's the inverse log, so to the negative 2. Okay, so if we second function log to the negative 2.00, we get 1.00 times 10 to the negative 2. Okay. All right, so now we have our hydronium concentration, but we need the hydroxide concentration. So A here would not be correct, because that would be the hydronium. So now we're going to use our ion product constant equation. Okay, so we have hydronium, and so we can solve for hydroxide. So we can isolate our hydroxide on one side. We have this handy dandy number that you all hopefully have memorized or are going to. So we can divide 1.0 times 10 to the negative 14 by 1.00 times 10 to the negative 2. Okay, and so when we do this, we should get the same answer. So you can go ahead and check on your calculators. Once again, you may need to use parentheses around each of the numbers that you plug in, or you may get a wrong answer. A lot of the times it'll be off by so many decimal places instead of the correct 10 to the power of 12. It could be off by a few powers if you don't use your calculator correct. Okay, and so B once again. So there's two routes that you can take to answer this problem. We have now gone through all of the pH equations. Okay, so if you need to refer back to your book or to the video where we talk about all of the equations, so pH is equal to negative log of hydronium concentration. Be sure you know your ion product constant, as well as the scale. So the pH scale is from 1 to 14, so pH plus pOH has to equal 14. Okay, and so if you will go now and just practice. So practice, practice, practice on homework, as well as the extra practice that I have provided for you in Blackboard. Thank you.